This lesson is about permutations and combinations. And we're going to use permutations and combinations to solve real-life problems. And we're going to have a nice formula that we can put into our calculator and come up with our answers on here. But the key is going to be to decide, do I have a permutation or do I have a combination? So let's start with our permutation. And our permutation is the arrangement of objects in which order is important. For example, how many ways can the letters A, B, and C be arranged? So I need to arrange these three letters, A, B, and C. So let's look at our possible ways of doing this. I can have A, B, C. I can have A, C, B. I can have B, A, C, B, C, A. And I can have C, A, B, C, B, A. So I'm going to have 6 ways. Now, this was an easy question because I only had 3 letters. So I could figure out the different ways of coming up with writing A, B, and C in different order. What happens when we have 6 letters, for example, and we're trying to figure out how many ways I can rearrange 6 letters? That's going to take a little longer, and I'm going to have a whole lot more ways to come up with those 6 letters written in different order. So we're going to need some formulas in order to figure this out. Our permutation and combination formulas have something called factorial in it. And so let me explain what factorials are, and then we'll go over the formula for permutation. So n factorial, this is by definition, n factorial is going to be our n times n minus 1 times n minus 2 times n minus 3, all the way until you get down to 1. So if we look at the example of 5 factorial, we're going to get 5 times 4 times 3 times 2 times 1. And you'll notice to the right here I have a graphing calculator. And if you go into math, you push math on your graphing calculator, and then you need to highlight the probability symbol. So you'll have to either use the arrow, go over 4 times, or go to the left once. And you'll see these options here. I have permutation, I have combination, and I have our factorial. And so that is what we're going to be using on our calculator. So I can either take 5 times 4 times 3 times 2 times 1 by hand, or I can use 5 factorial on my calculator, and I should come up with 120. So 5 factorial is going to be 120. Now, if we think of the last example I just went over, I had 3 letters. So we can use the factorial. This is how it would work. We'd have 3 factorial, which is 3 times 2 times 1, which would end up giving us 6. And that's how many ways we came up with the letters, rearranging the letters A, B, and C. Okay. One thing to point out here is 0 factorial is always going to be 1. Not that it really makes sense, because if you have 0 to start off with, doesn't make sense that you'd end up with 1. But because of our math formulas for permutation and combination, we need it to be 1 so that we can use our formulas for all cases, and we won't end up having 0 in the denominator. So here's our permutation formula. And the way we'll write it in this particular class is going to be in this format right here, the NPR. Okay, and that's the same way they write it in the calculator. Sometimes you will see it written like that. Okay, that's just another form of writing the same thing. But our formula basically says we have n factorial over n minus 4 factorial. So for an example, if I have 5p3, then what I have here is 5 factorial over 5 minus 3 factorial. And I have 5 factorial over 2 factorial. I'm going to write this one out the long way. We can actually put what I have here right into the calculator and get my answer, but I just want to show you what happens when we write this out the long way, in case you do not have a calculator. I end up with this, and you'll notice that my 2's can reduce. My 1's obviously don't have value here when I'm multiplying and dividing. So I end up with just 5 times 4 times 3, which gives me 60. Okay, I can put what I have here in the calculator using my NPR button, and then that way I will come up with the same answer. Let's do a couple more examples using our calculator. So here I have an example of the permutation of 10 things taken 2 at a time. So I have 10 total items taken 2 at a time. And my permutation formula says that I will have 10 factorial over 10 minus 2 factorial, which is 10 factorial over 8 factorial, which will end up giving me 90 if I go through and calculate that. Or I just use my calculator. I can enter this into my calculator, and I will come up with the same exact answer. What about this permutation of 6 things taken 6 at a time? So watch what happens when I use my formula here. I end up with 6 factorial over 0 factorial, and here you can see why 0 factorial is going to be 1. I cannot have 1 in the or 0 in the denominator of a fraction, so it's not possible to have 0 factorial equal 0. So we have it equal 1, so mathematically we are consistent here, and we can follow our rule, and I end up with just 6 factorial. And so I have 720. Now let's look at combinations. So here we have combinations. A combination is a selection of objects where the order in which the objects are chosen is not important. Okay? In permutations, remember, I was trying to figure out the order of A, B, and C. So obviously the order is important. So an example here is picking a group of 3 out of 10 people. Doesn't matter if I have A, B, C as my 3 people, or if I have C, B, A, that counts as one group of 3 people. So what ends up happening with our formula for combination, and I use a C here for combinations, I'm going to take my permutation of that n things taken r at a time, but I'm going to divide out the r factorial because I'm going to divide out the ones that are repetitive, the ABC and the CAB, which are the same thing. Okay, so I have n factorial over n minus 4 r factorial times r factorial. And when we're reading this, we'll say the combination of n things taken r at a time, or n choose r is an easier way to say combinations. Okay, let's do a couple examples here, and I'm going to actually do a couple of these without a calculator first, and then we can use the calculator to show our answer. So here I have n choose 3. Okay, so I'm going to take the 12 factorial over 12 minus 3 factorial times 3 factorial. So I get 12 factorial over 9 factorial times 3 factorial. When I write this out the long way, and I'm not going to write everything, because my 12 factorial is going to be 12 times 11 times 10 times 9 times 8, and so on all the way to 1. But my 9 factorial is going to be 9 times 8 times 7 times 6. So everything will cancel out, but the 12, 11, and the 10. 9 and on is going to cancel out with my 9 factorial down here. So that's all I'm going to have in the top. And in the bottom, I'm still going to have my 3 times 2 times 1. So without a calculator, I could easily go through and do some simplifying here. And I end up getting 2 times 11 times 10, or 220. Okay? Or you use your calculator, go into that same button where you push math, go and make sure you push the one that has a C on it so you get the combination, and you will come up with the same answer. So when we look at this next example here, I'm going to have 9 factorial over 9 minus 9 factorial times 9 factorial. So once again, I'm going to get that 0 factorial, which is going to equal 1, and I have 9 factorial over 9 factorial, which gives me 1. If I have 9 items and I need to pick a group of 9, I'm going to have one way of picking that group of 9, so that makes sense. So let's look at some real-life situations where we'd have to use permutations or combinations. The first example I have is that there are 5 basketball players needed to play from a team of 12. How many different groups of 5 players can be picked? So the first thing I want to do is I want to look at here and I want to say, okay, how many different groups of 5 players can be picked? Is the order important or is it not important? Do I have to pick those 5 players in certain spots, or am I just picking a group of 5 players? So because I'm picking the group of 5 players, this is going to be a combination. So I'm going to have 12 total players, and I'm going to take the combination of them 5 at a time. So I have 12, choose 5, or the combination of 12 things taken 5 at a time. And I can either use my formula, or I can just use this on the calculator, which is what I'm going to do at this point. And I get 792 different combinations of taking 5 basketball players from a team of 12. So here's another example. The 10th grade needs to pick a president, a vice president, and a secretary from 50 students. How many ways can they be picked? Okay, so you'll notice in this situation, I'm picking a president, a vice president, and a secretary from 50 students. Okay, does it matter if I have Jim as president, Mark as vice president, and Sarah as secretary, and I switch that around and put Sarah as president, Jim as vice president, and Mark as secretary? Those are two separate options. So in this case, order does make a difference because I have positions that I'm putting those 3 people into. So I'm going to use permutation on this one. I have 50, the permutation of 50 things taken 3 at a time. The other way to look at this is you have your 3 spots, your president, your vice president, and your secretary. And I'm going to come up with, look back at our counting principle, how many different students can I put for president, how many for vice president, and how many for secretary. Or I just use my calculator to compute this. So I end up getting 117,600 different ways of picking a president, vice president, and secretary, which seems like a large number, but I also have 50 students that I'm working with. So another example, there are 6 essay questions on your exam, and you need to answer 4 of them. How many ways can 4 questions be selected? So does it matter if you answer question 4, 3, 2, 1, or 1, 2, 3, 4? In this case, you just want to pick 4 questions. And if you pick 1, 2, 3, 4, it's going to be, those are the same 4 questions as 4, 3, 2, 1. So I'm going to be using combinations. I'll have 6 questions that I need to choose 4 from. So I'm going to use my combination button. And I end up getting 15 different ways. So you'll notice one thing about the combinations and permutations, and it makes sense from the formula, but your combinations are going to be smaller than your permutations. If you're using the same numbers, you're going to have less combinations because the repetitive, the 1, 2, 3 is the same as the 3, 2, 1. So let's look at our last example. There are 10 runners in the race. How many ways can the first 3 finishers come in? So I'm looking, in this case, I'm looking at 3 finishers, which means I'm having a first, a second, and a third. Okay? Does it matter if I switch my first and my third? Yes. Then I have a different first place winner than I would if I had the other situation. So in this case, I'm looking at permutation. So I have the permutation of 10 things taken 3 at a time. And I get 720. So there are 720 ways of coming up with a first, second, and third place when I have 10 runners.